1, 2, and 3 are finding trigonometric ratios from a point on the unit circle. Again, if we have the point that x is equal to the cosine, which is the adjacent over the hypotenuse, the y is the sine, which is the opposite over the hypotenuse. So, if I have my triangle, this top number here would be the adjacent, so it's going to be 3 over the hypotenuse, which is 5. The top number here is going to be the opposite, and actually it's going to be negative 4. So I'm going to be going down. So 3, 5, and negative 4, since this is my adjacent, my opposite, and my hypotenuse. Now I'm going to find the exact values, and now they're going to throw in more than just the 3 basic ones. So we had the sine, which was the opposite over the hypotenuse. The inverse of the sine is the cosecant. The cosecant is the hypotenuse over the opposite, just flipped upside down. Cosine was adjacent over hypotenuse. The secant is that inverse, so hypotenuse over adjacent. Tangent was opposite over adjacent. Cotangent is going to be adjacent over opposite. So we're going to do the cosecant, the sine, and the cotangent. So my cosecant, my hypotenuse over my opposite. My sine's going to go the other way around, my opposite over my hypotenuse. And my cotangent, my adjacent over my opposite. So, hypotenuse over opposite, 5 over negative 4 would be negative 5/4 then. Sine is the opposite over the hypotenuse, so negative 4 over 5, negative 4/5. Cotangent is the adjacent over the opposite, 3 over negative 4, so negative 3/4. Now hopefully you have those written down. I got to move the board here. So on number 2, again, since this is the cosine, this is going to be the adjacent over the hypotenuse, and this will be the opposite over the hypotenuse. So my adjacent's going to be negative 15, and my opposite's going to be 8. My hypotenuse is going to be 17, which tells me I have to go negative 15, 8. So negative 15, 8, and 17 would be my triangle. My tangent. Tangent is opposite over adjacent. My cosecant is opposite of sine, so it's the hypotenuse over the opposite. And my cosine, and I'm going to stick it down here, cosine is the adjacent over the hypotenuse. So my tangent, my opposite over adjacent, so I'm going to have negative 8/15. Cosecant, hypotenuse over the opposite. So hypotenuse over the opposite, 17 over 8. And then cosine, adjacent over hypotenuse, negative 15/17 then. Of course on Alex they always put the negative in front of the fraction. And the third one here. We would have my adjacent over my hypotenuse and my opposite over my hypotenuse. So my adjacent is square root of 2, my opposite is square root of 2, and my hypotenuse is 2. So, since those are both positive, we are going to have square root of 2, square root of 2, square root of 2, and 2. So both my adjacent and my opposites are square root of 2. We want to do the secant, the sine, and the tangent. The secant is opposite of the cosine, so it's going to be hypotenuse over adjacent. Sine is opposite over hypotenuse, tangent opposite over adjacent. So my hypotenuse over my adjacent would be 2 over the square root of 2, but of course I have to rationalize the denominator. So I get 2 square root of 2 over 2. Those would cancel out. Just gives me square root of 2. My sine, opposite over hypotenuse, square root of 2 over 2. And my tangent, opposite over adjacent, square root of 2 over the square root of 2, just gives me a 1. So I get square root of 2, 2 square root of 2, and 1 for my 3 answers. So again, just double check, sine is the opposite over the hypotenuse. The inverse of sine is cosecant, so hypotenuse over opposite. Cosine is the adjacent over the hypotenuse. The inverse of the cosine is the secant. The secant would be the hypotenuse over the adjacent. Tangent, opposite over adjacent. Inverse of that is cotangent, so adjacent over opposite. You'll be using those quite a bit, so you'll want to keep a list handy. Okay, 4, 5, and 6, we're finding the exact values of the angles given below. And again, so first of all, the sine is the opposite over the hypotenuse. The cosecant is the hypotenuse over the opposite. The cosine is the adjacent over the hypotenuse. The secant is the hypotenuse over adjacent. Tangent, opposite over adjacent. Cotangent, adjacent over opposite. So here we want to find the cotangent of negative 2 pi over 3. Negative 2 pi over 3, if I change it to over 6, would be negative 4 pi over 6. So if I go negative, 1 pi over 6, 2 pi over 6, 3 pi over 6 would be right on the line. So 4 pi over 6 would be here, which means that this is going to be a 60-degree angle. That one would be 30. So 1, 2, square root of 3, but this is going backwards, so it's negative. This is going down, so it's also negative. So I've got my reference triangle there. I want to do the cotangent. The cotangent is the adjacent over the opposite. So my adjacent is negative 1. My opposite is negative square root of 3. Since I have a negative over a negative, it's a positive. 1 over square root of 3. I have to rationalize the denominator. So I'm going to get the square root of 3 over 3. The secant is the hypotenuse over the adjacent. The hypotenuse is 2, the adjacent is negative 1. 2 over negative 1 would give me negative 2 for my answer. Number 5, this time we want to do a positive 7 pi over 4. So those are 45-degree angles. 1, 2, 3, 4, 5, 6, 7 pi over 4 would be over here in quadrant 4. So we've got 1, 1, and the square root of 2. This is positive, but the down direction is negative. And so now we want to do tangent. Tangent is opposite over adjacent. So the opposite is negative 1, the adjacent is positive 1, negative 1 over 1 is 1. The cosecant is the hypotenuse over the opposite. Hypotenuse is square root of 2, the opposite is negative 1. Square root of 2 over negative 1 would be negative square root of 2. I'm going to sneak number 6 in there. So on here we're doing a positive 3 pi over 4. So again we're doing 45s. 1, 2, 3 pi over 4. 45 means it's 1, 1 and the square root of 2. But this one's going backwards, so that one's going to be a negative 1. Secant, hypotenuse over adjacent. Square root of 2 over negative 1. which is negative square root of 2. Tangent, opposite over adjacent. So opposite is 1 over the adjacent. 1 over negative 1 is negative 1. So those would be my answers. So again, using my reference triangles, my 30, 60, 90, and my 45, 45, 90. If you get those memorized, it's going to make a whole lot of these problems a lot easier than having to look up things in charts and tables all the time. Seven, 8, and 9, pretty much like we did before, only now we have a little bit more tricky things in order to figure out. So here we have 10 pi over 3. When we figure out our angle, we want it to be pi over 6. So 10 pi over 3 is the same thing as 20 pi over 6. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So that's going to make this a 60-degree angle, that one the 30-degree angle. So 1, 2, square root of 3. This is going to be negative, this is going to be negative. My cotangent. On my cotangent, I'm going to have the adjacent over the opposite. So my adjacent is negative 1. My opposite is negative square root of 3. Since I have a negative over a negative, it's going to be 1 over the square root of 3. And if I rationalize my denominator, I'm going to get the square root of 3 over 3. On my secant, again, this is a negative 1, so I'm going backwards around. So if I take 360 and subtract 225, I get 135. So 135 would be over here. That's leaving me a 45-degree angle. So I would have 1, 1, and the square root of 2. This side's going back, so it's actually a negative 1. Secant, inverse of cosine, would be the hypotenuse over the adjacent. My hypotenuse is the square root of 2. My adjacent is negative 1. So square root of 2 over negative 1 would be negative square root of 2 for my answer. Now you might have wanted to, on this top one here, figured out what it was equal to by subtracting 2 pi from it until you got something between 0 and 2 pi, and then you wouldn't have to count around so many times. So just for fun, if I have 2 pi and I subtract, actually I want to go the other way around since 10 pi over 3 is bigger. I want to take 10 pi over 3 and subtract 2 pi. 2 pi, if I take that times 3, 10 pi over 3 minus 6 pi over 3 would give me 4 pi over 3. Then if I make that, I would into an equivalent fraction. 4 pi over 3, if I make it over 6, would be 8 pi over 6. So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4, 5, 6, 7, 8. You can see I ended up in the same spot, but didn't have to count around 20 pi over 6 by making and simplifying my value. Since I know I went around once, I could take off the 2 pi, leaving me 4 pi over 3. Number 8, so I'm going to do the cosine of 570. Again, that's bigger than once around, so I'm going to subtract my 360 from it. 210. So 210 would be in quadrant 3. if I take 210 minus my 180, since 180 would be right to the line, that's not what we want to do. 210, 30. So this would be my 30-degree angle. So over here would be my 60-degree angle. So 1, 2, square root of 3, that would be negative, that would be negative. So cosine, for my cosine, I have the adjacent over the hypotenuse. The adjacent is negative square root of 3, the hypotenuse is 2, so I just get negative square root of 3 over 2. Here we're doing a negative 2 pi over 3. Again, I want to make it over 6, so I want to go negative 4 pi over 6. So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. That makes this the 60, and this one the 30. So this would be 1, 2, square root of 3. Of course, that's negative and that's negative since this is going backwards and this one's going down. Tangent. Tangent is opposite over the adjacent. So the opposite is negative square root of 3. The adjacent is negative 1. Since I have a negative over a negative, it's going to make that a positive square root of 3. Number 9, we have negative 180, which means if I take 360 and subtract 180, it's the same thing as a positive 180. Right? Negative 180 and positive 180, whether I go this way around or this way around, I end up on the same spot. And when you end up right on the line, it's kind of a unique situation. What you're saying here is that this value here is going to be 1, but it's going backwards, so it's going to be a negative 1. You're going up 0, so this value here is going to be 0, and your radius is going to be 1, because if you use your Pythagorean theorem, a squared plus b squared has to equal c squared. So this is what my triangle is going to look like, but since it's right on the line, I really don't have a triangle, but I'm going to draw it because that's going to be a 0 in there. I want to do the cosecant. The cosecant's opposite the sine, so hypotenuse over opposite. My hypotenuse is 1, my opposite is 0. 1 over 0 is undefined, and that's why they have that choice that says if it's undefined, click on undefined. The next one we're doing negative 5 pi over 6. It is over 6, so 1, 2, 3's right on the line, 4, 5. That means that's the 30-degree angle. So 1, 2, square root of 3, that's negative and that's negative since I'm in quadrant 3. Secant, opposite of the cosine, so hypotenuse over adjacent. My hypotenuse is 2 over my adjacent, negative square root of 3. I've got to rationalize my denominator, so I'm going to get negative 2 square root of 3 over 3 for my answer. So just keep in mind here, when it is right on the line, depending if it's the x or the y, if it's going up or down, then your opposite one's going to be 1 or negative 1. But your hypotenuse is always going to be 1. So you have two sides that are 1 and one side that's a 0, and could be negative depending on which direction it's going to. By the way, on some of these you could use your calculator. I haven't mentioned that before. But sine, cosine, and tangent, if I have the degree measure, I could use my calculator. If I put in cosine of 570, oh, it doesn't give me a very nice answer because I had this square root of 3 over 2, or negative square root of 3 over 2. My calculator, I get negative 0.866. But if I put in negative square root of 3 divided by 2, I get that negative 8.66. Same equivalent answer. So a calculator doesn't work very well since I want exact, unless it would happen to come out to something really nice, like 1 or 2 or negative 1. (10, 11, and 12, we're going to find the missing side. Based on that, we know that when we have a 45, 45, 90 triangle, that the sides opposite the 45s are 1, 1, and the opposite the 90 is square root of 2. And so I'm thinking about the equivalent fraction. If I have d over 2, then I would have to have the hypotenuse over 1. So square root of 2 over 1. Cross multiplying, d is just going to equal 2 square root of 2 then. Over here we've got that 30, 60, 90 triangle. And we know that the one opposite the 30 is 1, the hypotenuse is 2, and the other one is square root of 3. So we have 4 over c, so we're going to have the square root of 3 over 1. Right? We have that one side and that side. So cross multiplying, we would get square root of 3c equals 4. We then end up dividing by the square root of 3, and so when we rationalize, we get 4 square root of 3 over 3 for our missing side. So number 11, if I label these, this would be 1, this would be 1, this one's going to be the square root of 2. So d over 7 is going to equal 1 over square root of 2. So we're going to have the square root of 2d equals 7. We have to divide by the square root of 2. So when we rationalize, we get 7 square root of 2 over 2. It's not a very good way to write it. 7 square root of 2 over 2. When we look at the other one, the one opposite the 30 is 1, the hypotenuse is 2, and the other one opposite the 60 is square root of 3. So if I say h over 8, I'm going to do the square root of 3 over 1. I like it when there's the 1 there, because now h equals 8 square root of 3, and I don't have much to do to solve that. There we go, 12. So this time we have our 30, 60, 90 first. So the one opposite the 30 would be 1. Hypotenuse is 2, square root of 3. So 5 over a is going to equal the square root of 3 over 1. So square root of 3 times a equals 5. I've got to divide and rationalize my denominator. So I'm going to get 5 square root of 3 over 3 for my answer. On my other one, 1, 1, square root of 2. So h over 8 would equal square root of 2 over 1. So h is just going to equal 8 square root of 2. There's one of those easier ones that I like. So just using the ratios of my standard 30, 60, 90 triangle or my 45, 45, 90 triangle. The next ones we are going to use a calculator to approximate sine, cosine, and tangent. And on Alex, it's going to say use your Alex calculator. I added in or your own. It doesn't matter which one you use. And so we're going to just do the 3 basic ones, cosine, tangent, and sine. Your calculator should be in degree mode. So if you find you're not getting your right thing, make sure that your calculator is in degree mode. And so if you hit mode, mode, and number 1, that's going to put it in degree mode. Mode twice and then number 1 for degree. So cosine of 51 degrees, you're just going to hit cosine 51, hit equals. We're rounding to the nearest 10 thousandths. So 0.62932, tenths, hundredths, thousandths, 10 thousandths. I've got to carry it 5 places and then round it off to 4. So 0.6293, since there's a 2 behind there. Tangent of 30. tangent of 30. I get 0.57735. There's a 5 behind that one, so 0.577, and I've got to round that one up to 4 then. Sine of 88. Sine of 88 gives me 0.99939. So 0.999, and again I've got to round that one up to 4 since there's a 9 behind there. So cosine of 75, cosine of 75, 0.25881, so 0.2588 is where I'd round that off. Sine of 21 degrees, 0.35836, so 0.3584, because I have to round that one up to the next bigger number. And then tangent of 58. We get 1.60033. So 1.6003 is where I would round that one off to. And the last 3 there. Tangent of 49. Tangent of 49. 1.15036. So I've got to round that one up, 1.1504. Sine of 63, 0.89100, so 0.8910. Again, we want to show to the nearest 10,000, so they are going to show that 0 in the 10,000 spot. Cosine of 17, 0.95630, so 0.9563 would be rounding it off to the nearest 10,000ths. So just a matter of using your calculator. Since these are in degree mode, making sure your calculator is in degree mode and just punching it in. The next ones, we're going to use the Pythagorean theorem to find our missing sides so that we can find cosine, tangent, sine, whatever they might ask for. So Pythagorean theorem says that a squared plus b squared equals c squared. So the 2 legs equals the hypotenuse. So 12 squared plus b squared would have to equal 13 squared. B squared is going to equal 13 squared minus 12 squared. You could figure those out, but I'm just going to put it in my calculator like that. 13 squared minus 12 squared is going to give me 25. So b squared equals 25, which means b equals the square root of 25, which happens to be 5. So that side is 5. We want to do the cosine. The cosine is the adjacent over the hypotenuse. The adjacent is 5, the hypotenuse is 13, so 5/13 is going to be my cosine. The next one, 5 squared plus b squared equals 6 squared. So b squared is going to equal 6 squared minus 5 squared. 6 squared minus 5 squared is going to give me 11. So b is going to equal the square root of 11. Can't do much with that. We want to do the tangent. Tangent is opposite over adjacent. So opposite is 5, adjacent is square root of 11. We have to rationalize that denominator. So 5 square root of 11 over 11. I'm just assuming that you know when you take the square root of 11 times the square root of 11, you get the nice plain 11. You get the square root of 121, which is 11. So skipping that, assuming that you can do that in your head, or if you need to, on your paper. And the next one here, if we look at number 18, we would say that 9 squared plus b squared equals 10 squared. So b squared is 10 squared minus 9 squared. 10 squared minus 9 squared is 19, so b squared equals 19. B is going to equal the square root of 19 then. And we're doing the sine. Sine is the opposite over hypotenuse. The opposite is the square root of 19. The hypotenuse is 10. So we get square root of 19 over 10 for our answer. So just using our Pythagorean theorem to find our missing sign and then doing our angle, sine, cosine, tangent, whatever they might ask for. 19, 20, 21, again, using the Pythagorean theorem to find our missing side, knowing that sine is opposite over hypotenuse, cosecant is hypotenuse over opposite, cosine is adjacent over hypotenuse, secant is hypotenuse over adjacent, and tangent is opposite over adjacent. Cotangent would be adjacent over opposite. So knowing our 6 basic trigonometric functions and the Pythagorean theorem. A squared plus b squared equals c squared. C is always a hypotenuse. So 7 squared plus b squared equals 8 squared. B squared then is going to be 8 squared minus 7 squared. I always am hiding my calculator. So 8 squared minus 7 squared is 15. B squared equals 15, so b is the square root of 15. And we are going to do tangent, cosine, and cosecant. Tangent, opposite over adjacent. So the opposite is square root of 15, adjacent is 7. So square root of 15 over 7. Cosine, adjacent over hypotenuse. The adjacent is 7, the hypotenuse is 8, so 7 over 8. Cosecant, hypotenuse over opposite. My hypotenuse is 8, my opposite is square root of 15. We have to rationalize that. So we get 8 square root of 15 over 15. So, same kind of thing on the next one. 8 is my hypotenuse, so 3 squared plus b squared equals 8 squared. B squared is then going to be 8 squared minus 3 squared. 8 squared minus 3 squared gives me 55. So b is going to be the square root of 55. Sneak that in there. I'm going to do the secant, the tangent, and the sine. So the secant is the hypotenuse over the adjacent. So hypotenuse is 8, adjacent is square root of 55. 8 over the square root of 55 I have to rationalize. And so I get 8 square root of 55 over 55. My tangent, opposite over adjacent. Another one that I'm going to have square root of 55 then. Opposite is 3. So 3 over the square root of 55, rationalizing my denominator, I get 3 square root of 55 over 55. And my sine, opposite over hypotenuse. The opposite is 3, the hypotenuse is 8, that one makes it easy, 3 over 8. And 21. So 21, we're missing the hypotenuse. So 7 squared plus 5 squared equals c squared. 7 squared plus 5 squared is 74. So the square root of 74 is going to be what our hypotenuse is. We want to do cosecant, sine, and cotangent. Cosecant is the inverse of sine, so hypotenuse over opposite. Sine is opposite over hypotenuse. Cotangent is the opposite of tangent, so the adjacent over the opposite. So hypotenuse over the opposite. Square root of 74 over 5. Sine, opposite over hypotenuse. So 5 over the square root of 74. I've got to rationalize my denominator. So I get 5 square root of 74 over 74. And then we have the adjacent over the opposite, so 7 over 5. Like those ones, I don't have to rationalize my denominator.